Hi, in this tutorial we are going to solve a question related to SN2 reactions. The question asks us, you are given 4 pairs of molecules. In each case, state which molecule is expected to undergo faster SN2 reactions if same nucleophile and same solvent are used. Give a brief reasoning. Let's start solving the question. We have here A and B molecules for 4 cases, and we have to decide which molecule is expected to react faster in an SN2 reaction. Let's look at for the case A. For the first case, we have here 2 alkyl chloride, and let's look at these are the substrates, and let's look at this molecule. This is a secondary halide. Let's write here. This is a secondary alkyl halide. And let's look at this molecule. This is a halide, alkyl halide, and it is a primary halide. Primary halide. Okay, these are alkyl chlorides. And we know that in SN2 reactions, the substrate is important and it affects the rate of reactions. And generally, methyl is the fastest metal halides. In this case, this is chlorine and chlorine, so the same leaving group. So substrate will be the factor to determine the rate of reaction. Metal halides are fastest than primary halides, then secondary halides, and tertiary halides are the slowest in SN2 reaction. For that reason, B is expected to react faster than A. The reason B is a primary alkyl chloride and A is a secondary alkyl chloride. So we have same leaving groups and we have same nucleophile and we have same solvent. The only effect will be the substrate, and here substrate is less bulky, and here secondary alkyl halide is bulkier, and that's the reason why this reacts as slower. Let's analyze this situation with a molecular model. In this model, you have the modeling of an SN2 reaction, and it's kind of an animation. It's going to show you how an SN2 reaction can happen. So basically we have a nucleophile hydroxide. It is attacking methyl chloride and it is replacing the leaving group chlorine. So if you look at here, let's just stay here. This is the transition state. Where is the energy is maximum in energy graphics. If you look at here, the nucleophile is attacking to the substrate from the backside of the leaving group. So what may affect the rate of this reaction? Basically, if the nucleophile can easily approach to the carbon bearing the leaving group, we expect that the reaction will be faster. So in this case, we have all hydrogens around the carbon bearing the leaving group. So these are small groups. Hydrogens are small groups. So the reaction will be faster because they are not going to prevent incoming nucleophile. But if you replace hydrogens with alkyl groups like methyl ethyl, so we will have more bulkier substrates, and reaction will be slower because they are going to retard or slow down the reaction because the nucleophile will not be able to attack easily. So that is what affect here. Let's look at a second option. In the second option, we have 2 halides, but one is an alkyl iodide and the second one is an alkyl chloride. Let's look at the substrates, and this is primary. This is primary and this is still primary halide, and so basically the substrate steric factors are same, but we have 2 different leaving groups. So we know that leaving group affect the rate of SN2 reactions. Which leaving groups are best for SN2 reactions? The leaving groups who can stabilize the negative charge. Basically, the leaving group iodine will be an iodide anion, and the chlorine leaving group, when it leaves, it will be a chloride anion. We know that iodine is a bigger leaving group than chlorine. Iodine is expected to stabilize the negative charge more, so that's the reason why A, the first one, is expected to react faster than B. The reason it has a better leaving group. What is a better leaving group? Iodine will have a net negative charge, and chlorine will have a net negative charge when they leave after the nucleophilic reaction. But iodine is going to be able to stabilize the negative charge more with respect to chlorine, because chlorine is smaller in terms of atomic radius. For that reason, iodide anion will be more stable. That's the reason why A is going to react faster than B. Let's go to this third option. In the third option, we have, let's write here, an alkyl chloride and alkyl chloride. So we have same leaving group. Substrate here, we have the carbon bearing the leaving group. So it has two neighboring carbon. So this is a secondary substrate, and this substrate has also two neighboring carbon connected to carbon bearing the leaving group. So this is also a secondary alkyl chloride. So we expect that they may react with similar rates, but don't forget, for SN2 reactions, back attack to the carbon bearing the leaving group is essential for the rate of reactions. So if you have bulkier group, not exactly at that carbon but in the neighboring positions, that will also expected to affect the rate of reactions. So let's look at here. This is the carbon bearing the leaving group, so nucleophilic attack will be on this carbon, and in this substrate nucleophilic attack will be on this carbon. So secondary, but the first one has a neighboring carbon which has two bulkier methyl and one ethyl group, but in the second one the carbon bearing the leaving group has one neighboring carbon here, and it doesn't have any bulkier group. So we expect that B is going to react faster than A, even though they are both secondary, because in the A case, in the first case, we have bulkier group near to the carbon which is going to be attacked by nucleophile. Okay, let's move to the last option. Last option is very similar to the previous question. In this case, we have again two same leaving groups. We have iodine and iodine, so leaving group effect will be same. The substrate here is primary iodide, so it's primary, and this one is also a primary. So again, we are expecting similar rate of reactions, but don't forget the attack will occur to this carbon, the nucleophilic attack, and in A we have a neighboring carbon with one methyl group, but in B we have a neighboring carbon with two methyl substituents. So B is bulkier than A, so B is expected to react slower than A, so A is going to react faster than B. So we solved four sets of halides undergoing SN2 reactions, and we compare their rates, expected rates in an SN2 reactions. Thank you so much for watching.